Here we are again in our subject, organic chemistry. And our topic for this meeting is on aromatic hydrocarbons. But we will limit our discussion more on the double band or the alkene or the cycloalkene. Aromatic hydrocarbons has a molecular structure that incorporates one or more planar set of six carbon atoms that are connected by the localized electron numbering the same as if they consisted of alternating single and double covalent bands. The term aromatic was derived from the fact that many of the compounds has a sweet scent and was assigned before the physical mechanism determining aromacity was discovered. The configuration of six carbons is known as the Benzene ring, after the simplest possible such hydrocarbon, benzene. Many aromatic compounds are monocyclic and sometimes they are also polycyclic. Some non-benzene based compounds called heterocyclic also exist. Okay, benzene C6H6 is the simplest aromatic hydrocarbon or amines. It is sometimes abbreviated with PH-H. PH for the phenyl and H as the hydrocarbon for the hydrogen component. Benzene was recognized as the first aromatic hydrocarbon, with the nature of its bonding first being recognized by Friedrich August Kekulé von Stradonitz in the 19th century. Each carbon atom in the hexagonal structure has four electrons to share. One goes to the hydrogen atom and one each to the two neighboring carbons, in which one is in the form of double bond and the other one is a single bond. Many chemists draw a circle around the inside of the ring to show six electrons floating around in delocalized molecular orbitals. So here it is. This is the initial drawing of chemists, meaning to say this double band could move here, and this double band could also move here, and this double band could also be shown here. So that this structure of benzene could also look this way. So most often than not, in some higher organic books or in higher discussion of benzene, the ring itself is just simply drawn, meaning to say there are three floating double bonds between carbons. What are the general properties of benzene? Of course, they display aromacity. Benzene is an aromatic hydrocarbon, the second annulens, or the sixth annuline. A cyclic hydrocarbon with continuous pi band. That is, if you can remember your molecular cloud formula. The carbon to hydrogen ratio is very large in benzene. They undergo electrophilic substitution and resist addition reaction. Benzene is colorless. It is also an inflammable liquid with sweet smell and a relatively with high melting point. Under flame test, the color is a yellow salty flame. It is very pollutive in nature. These are examples of benzene derivatives. All of them have a sweet taste, especially with the case of phenol. The dentist-like odor or scent that you can smell in dental clinics and other hospitals is actually phenol. So you can see here that what makes them different is just simply the alkyl group attached to it. And then you have also monosubstituted benzene derivatives. So if the substituent contains 6 carbons or fewer, then the compound is named substituted benzene compound. An example of them are this one, monosubstituted. Okay, there are also some alkyl groups that could be attached to benzene rings. So they could be in a penyl structure or benzyl structure. This is a benzene ring in which the alkyl group could be this one. But however, if we're going to look at the IUPAC naming, the penyl ring is just simply an alkyl group. And the main carbon is this 8 carbon containing aliphatic compound. By the way, class, speaking about aromatic and aliphatic, when you will have your word exam, if you say aromatic, or if the exam will say or refer to aromatic, um, please condition into your mind that this aromatic compound that was referred to, sorry, refers to the cyclo or the ring structure of organic compound. That is the general description. However, there are some arguments that aromatic compound could be aliphatic, but generally in terms of theory and in terms of books, aromatic compound refers to the cyclo or to the ring structure. So in this case, you have the aliphatic compound, but the alkyl group is the aromatic structure. So in this case, you could still name this as aromatic compound, although the main structure is the aliphatic structure. Then we have also some structures here in which again the alkyl group is a benzyl or a benzene ring, and you have this as the aliphatic compound. So in this case, this is called substituted carbons. So these alkyl group are just simply substituents of an aliphatic compound. And then we have also some common names. If the alkyl group is a benzene and attached to a 1 carbon containing aliphatic compound, that is called toluene. And then this is styrene for the double CC bond. And then you have also here benzoic acid for your carboxylic acid. This is the carboxylic acid functional group. And then if it contains the aldehyde functional group, it is called benzaldehyde. And then you have here acetophenone for the quinone. And then for the carbon to nitrogen triple bond nitrile or benzonitrile. So if you notice, even the name starts with the main aromatic compound. So you have met this already. And then you have also disubstituted benzene derivatives. Meaning to say they have two R's or two alkyl group. If the R's are substituted between adjacent carbon bonds, they are called they hold the prefix ortho. But if there are two carbons away, then uh, they are called the meta. And then if they are at an opposite carbon, they are called the para. So in this case, you have two R groups, the methyl and the iodine. So how to write this? You have to write benzene, not necessarily writing cyclobenzene because benzene is already known as an aromatic compound. So uh, excuse if you're not going to write cyclo. So since you have two alkyl group, the ethyl and the iodo or the iodine, so arrange this alphabetically. Ethyl is letter E, iodine has the letter I. So ethyl is written first and then iodo. Just as the same, I could recommend to you the shortcut. Since this is benzene, you write benzene and then you write the alkyl groups. First, the one with a bigger letter and then in the alphabet, and then you have ethyl. So in numbering, the first carbon contains the one at the top, usually in the carbon side. So this is one ethyl and then one two iodo. And then we have here uh, nitrogen or nitrous and then bromine or bromo. So if we're going to look at here, alphabetic alkanes bromo, this is one, and that is nitro. In counting, we don't count 1, 2, 3, but rather we count to the nearest alkyl group. So in here, you have 1 bromo, 2, 3, nitrobenzene. And this case, chloro versus iodine. Chloro is letter C, iodine is I. So in the alphabet, this letter C comes first. So this is 1 chloro, 2, 3, 4, 4 iodobenzene. So you have also common names for benzene with two OH at opposite ends. They are called the hydroquinone. And then this is the resorcinol. Okay, many of these common names are acceptable parents, meaning to say you could use their name as the parent chain. So in this case, you have the orthobromotoluene. Toluene in a sense that you have one one carbon containing alkyl group. And then you have also polysubstituted benzene derivative. As you have made mention, poly, it has uh, many alkyl groups. So in this case, there are actually two bromine. So you have 3, 5 hydrobromophenol. Now why 3, 5? Because the main methyl group is the phenol. This one with OH. As you have made mention, the parent chain could be used as the main classification of the benzene. Okay. So in this case, chlorine, dichloro uh, was written first because uh, chlorobenzene, chlorobenzene is one parent chain. Okay, these are still some examples. Many benzene derivatives are also component of drugs, and presenting to you are just simply their what do you call this? Their name in the drugstore, generic name. So you have here your amphetamine, methamphetamine, and you have also here the acetyl salicylic acid. These are not over the counter drugs because these are only to be prescribed by a licensed physician. Licensed physician in a sense that they also have their own specialization. And then this is the formula for aspirin, and the generic name is acetyl salicylic acid. This is paracetamol. I am sure you have taken paracetamol as a pain reliever. This is picric acid, and then again, this is your salicylic acid. Salicylic acid usually comes in liquid, and it is used in some irritated skin. And then these are examples of substitution reaction of benzene. So these are the process, and then these are the reagents added. First you have here the benzene, and then the reagents added, and then you have here the products. If there is also such thing as polycyclic aromatic hydrocarbon, meaning to say they are not just simply aromatic hydrocarbon, they contain a lot of aromatic compounds, or they contain two adjacent aromatic compounds, or within the structure itself, they have two aromatic compounds. Example of this is your naphthalene. The naphthalene balls that you place inside the cabinet in order to drive away insects that could possibly destroy your wardrobe or your clothing. This is an old practice and still practiced today. And then all of a sudden, that naphthalene balls, and a few days, they were gone. So the change is from solid to gas. What do you call that? Review your general chem. And then there are two rings here. We have also with three rings, the anthracene, and then you have with four rings, the naphthacene, and then for five rings, you have the pentacene. So I repeat, for two adjacent rings, they are the naphthalene, for three, anthracene, four, naphthacene, five, pentacene. And then you have also here phenanthrene. What is the difference? This is um, adjusted with one another. The, the position of the metal ring is in that manner. Whereas in this case, the next or the middle uh, aromatic structure is placed at the top. And then you have here the chrysene. It has also four um, rings, but as sorry, but as compared with naphthacene, the chrysene two rings had been placed on top of the second ring. Uh, at my back is supposed to be benzoapyrene. Benzoapyrene is that compound found in your charred barbecue or roasted foods that is black in color. Uh, Benzoapyrene has 5 rings, uh, and then these are carcinogens. They are the carcinogenic compound found in foods that are usually charred when roasted. We have here also pyrene, just simply pyrene. It has 4. And then you have here coronine, you have here ovalin, and then you have here triphenylene. I do not know what is in my bag. But I am sure the main difference is this is benzene. The one at the center is benzene, whereas in this case, you have only 1, 2, 3, 4, 5 carbons. As compared here, it has 6. But I am not just simply sure if there are rings around. I have made mention this already. Then you have also heterocyclic compounds, and most of them have other elements aside from carbon and oxygen. They could have nitrogen, oxygen, and sulfur. So within the ring here, you have nitrogen. This is the pyridine. When it has 2 nitrogen, you have the pyrimidine. As I have made mention, these are still some examples of heterocyclic, polycyclic compound, and they are still called aromatic compound. Not necessarily cyclic or cyclo, but generally they are called aromatic compound. So that ends our topic for aromatic compounds.